welcome back to your favorite intermediate algebra course. We're going to solve some rational equations today. So we're going to use some of those processes that we used in the last couple sections to help us to simplify. So if you look at this first one here, 4/3 minus 7 over x, we're going to go ahead and you want to get, you see how you got two terms here, right? Two rational expressions, if you will. There, you want to merge those into ones, okay? So you want to get this into one rational expression here. Okay, so we're going to go ahead and get a common denominator, okay, for that side and merge them into one. And oftentimes it's easier just to get the same common denominator from both sides. Okay, so you're looking at this 4/3, 7 over x equals 1/6. So get a common denominator for that 3, the x, and the 6. Okay, so number wise, we're going to get a common denominator of 6. So go ahead and multiply that by 2, both sides there. Give this a 6. Okay, and we already got the 6 on that right hand side. Okay, so far we got 6, that's got a 6, that's got a 6, right? Now you notice the x here. Okay, that's the only one with the x. You got to give it an x here, give it an x here, give this an x here, give that an x there. Okay, so now you got 8x minus 42, and it's all over this 6x. So we just got a common denominator, both sides, the same common denominator. Okay. Now what you do is you just use the old multiplication property of equality. So we can multiply this side by 6x, okay? And you notice that'll cancel. Well, if I multiply the left-hand side by 6x, I got to multiply the right-hand side by 6x. And you notice the 6x's cancel. Okay, so by getting a common denominator on both sides, you got one rational expression on each side, or one fraction if you like to think about it that way, then you're left with the numerator. So 8x minus 42 ends up having to be equal to x. Okay, you add 42 on both sides. Okay, so that'll be gone there. We're also going to have to get rid of this x. We got to combine those like terms of the left-hand side. Okay, so we got 8x minus 1x is 7x equals, we got 42 over there. So divide by 7 both sides, and x equals 6. And then we go ahead and we plug it back into the original, and we double check, is 6 really the answer? And it is. Okay? So again, get one term on each side, if you will, one fraction on each side, okay, by getting a common denominator. So let's look at this next one here in blue. We got 2x in our denominator, we got a 3, and we got the 12 there. Okay, so let's get a least common denominator of 12x. Okay, so right now we have 2, 3, and 12. So again, we know that least common multiple is 12. So we're going to give this a 4, give this one a 6. Okay, you see how so far we got 12 on each of them, right? We got 12, 12, 12 on each of them. And then this one's got an x, right? But the other ones don't have an x. So give it an x, give it an x. Okay, so now we got 42 minus 20x, and it's all over this 12x, our least common denominator. And on the right hand side, we just got x over 12x. Okay, and at this point, we multiply this side by 12x, right? So that's gone. Got to multiply the right hand side by 12x. Okay, so we got 42 minus 20x equals x. Solve for x. 42 equals 21x. Divide both sides by 21. X equals 2. Plug it in. Check to make sure it worked in the original equation, and it does. There you go. You got your answer. Okay. Now let's do one where you actually end up with an extraneous solution. Okay. So let's go to this one. X plus 6 over x plus 3 equals 2 minus 5x plus 12 over x plus 3. Okay, let's get make sure we get, the right-hand side needs to be one rational expression, right? We got to combine those. So right now it's just 2 over 1. Whereas this, we got that x plus 3 right there, don't we? See how we have that x plus 3? So we got to give this an x plus 3. And you notice the left-hand side of the equation already has that common denominator of x plus 3. Okay, so let's write this now. We got x plus 6 equals 2x plus 3 minus this 5x plus 12 all over x plus 3. Of course, we got x plus 3 as our denominator here on the left-hand side as well. Okay, so we got to clean this up a little bit. So we go through and clean this up. Okay, so we got combined like terms. So we have that 2x minus the 5x. I circled those. That's negative 3x. We got the boxes there. 6 minus 12. It's a minus 6. Got this over x plus 3. And the left-hand side still the same. Okay, now at this point, you see how we got one fraction equaling one fraction, right? One rational expression on the left-hand side, one rational expression on the right-hand side. This is the point we wanted to get to. This is why we got that common denominator. So now we get rid of those denominators. So I multiply by x plus 3 this side, right? You see how the x plus 3's cancel there? Okay, that means I got to multiply by x plus 3 on this side. And you notice the x plus 3's cancel, right? So at this point, now we got x plus 6 equals negative 3x minus 6, okay? So we go ahead and solve that. So let's add 3x. We got 4x plus 6 equals negative 6. We're going to subtract 6. 4x equals negative 12. Divide by 4, and we got negative 3. Okay, so x equals negative 3 is our proposed solution, but it's real easy to tell who's going to give us problems. If you go back, so you're wondering, is this really a solution or not, right? Negative 3. Go back to the original. And you're like, wait a minute. If I plug in negative 3 right here, right, and I check this thing, negative 3 plus 3, that gives me a 0 in my denominator, okay? That means this is definitely an extraneous solution. Okay, that's extraneous solution. So for this problem, since there's no other proposed solutions to check, I just say, you know what, this has no solution. Kind of annoying that you have to do all that just to arrive at no solution. So make sure you're checking those, right? When you're doing a problem. In fact, you might want to look at it right off the bat here. You know, if you're looking at this problem, you say, well, I know right away 2 is not going to work out, right? Because 2 would cause us to be 0. And guess what else? 1 is not going to work out either, right? I cannot have a 2 or a 1. So if those end up being possible solutions, I'd throw those out. Those are extraneous. Okay, but let's go ahead and do this one. You notice the right-hand side here has two terms, right? We got the 2, then we got the plus that rational expression. So we got to get a common denominator again. So right now it's just 2 over 1. Okay, so I'm going to go ahead, I'm going to give this an x minus 2, and I got to give it an x minus 1. Okay, so now I got 2, x minus 2, x minus 1, plus this 12, and it's all over. Now these guys got a common denominator of x minus 2, x minus 1, okay? This side we got 3x minus 1 over x minus 2, okay? And at this point I can say, let's get rid of this, you know, denominator here, x minus 2, x minus 1. So we multiply this side by x minus 2, x minus 1. Okay, you notice those are gone. That means I got to do it to the right-hand side. So x minus 2 and then x minus 1. Sorry, I ran out of room there. Okay, you notice the x minus 2's cancel there. So on the left-hand side now, we have x minus 1. We got this 3x minus 1 equals, okay, and then I got all that 2, x minus 2, x minus 1, and a plus a 12. Okay, let me FOIL this first. then we'll distribute the 2. So we got 2. So we got x squared, I'm foiling, right? Minus x minus 2x, so that'll give me a minus 3x, and then negative 2 times negative 1 is a plus 2, right? Okay, go ahead, distribute the 2. Foil that one, combine like terms, right? You got 3x squared minus x minus 3x plus 1. So combine the bx terms, so you end up with 3x squared minus 4x plus 1 on the left-hand side. All right, now we can combine our like terms, right? So we're onto one side, so use the subtraction property of equality here. Okay, that's gone. Leaves us with 3x squared minus 2x squared is 1x squared. Let's go ahead and add this 6x as well at the same time. Okay, so you got negative 4x plus 6x, you got positive 2x. Okay, and now you notice I'm solving a quadratic. You know, it's of the form ax squared plus bx plus c. So if I'm solving a quadratic and I have it as bx term, I better get one side equal to 0, right? So you notice right here I have 4 and 12, right? So a plus 16. So I got to get this to the left-hand side. 1 minus 16 minus 15. So that on the right-hand side I got 0, right? Because when I'm solving a quadratic with that bx term, I want to get one side equal to 0. So that at this point I can either factor it or use a quadratic formula, however you want to approach that, complete the square and so on, okay? So I got one side equals 0 because I got this quadratic, all right? Factors of 15, 5, and 3. One's got to be positive, one's got to be negative, you know, check it, make sure that that one is the correct factorization, it is. And then solve. Okay, so we got this negative 5 by subtracting both sides. I got the 3. Okay. Now, so we go back. Now go back up to it, and you want to check it in the original. Okay. Now let's do it just a shortcut check. We originally said we can't have 2. Remember that? Can't plug a 2 in because it'll give me a 0 in the denominator. And over here, same thing, 2, can't have 2 there. We can't have a 1 either, right? 1 minus 1, 0. Okay, that will be problematic. So either of those, there we go, would not work. So, you know, you check it in formally, and those are going to work out for you. Plug it in formally. Okay, so negative 5 and 3 are going to work out. That's your solution on that one. Okay. All right, let's solve another one here. 3x minus 2 over x squared minus 3x equals 4 over x minus 4. Okay. Now this one you notice that you already have one fraction on the left-hand side, one fraction on the right-hand side, don't you? Okay. So you could go about getting a common denominator of both sides if you wanted to, or you could just say, you know what, at this point, I'm just going to multiply and get rid of my denominators here. So I'm going to multiply this side by x squared minus 3x. You notice that'll cancel that, right? Which means I got to do this side by x squared minus 3x, right? So now I would have, let me rewrite this. Now let's get rid of the old x minus 4. So I'm just going to use the old multiplication property of equality as well. So let's multiply this side by x minus 4, which means I got to multiply this side by x minus 4, okay? Some of you might think of doing the same procedure as cross multiplying. You know, if you have one fraction equaling one fraction, you can cross multiply. Okay, so anyways, here's the point we're at. X minus 4 times 3x minus 2 equals that 4x squared minus 3x. And then we're just going to clean this up, solve it. So we got 3x squared, I got a minus 2x minus 12x plus 8, 4x squared minus 12x. Okay. Get one side equal to 0. Well, let me combine those first. Let me take this 3x squared over. So I'm going to get the left-hand side to be 0. Let me add this 14x. gone. Let me subtract this 8 as well. So we got 0 equals x squared plus 2x minus 8. Go ahead and factor that. Use the zero product property. Okay. So at this point right here, -4 and 2, and then you want to say, you know what, does either of these work? What could we not have had? Let's look up at the original here. So looking at this x squared minus 3x, now I know this is not in factored form, but had it been factored, I would have said right here, it cannot be 0, that's problematic, and it cannot be 3, right? As well as, look at the x minus 4, right? It cannot be 4 either. So 0, 3, or 4 are going to cause us to have extraneous solutions. 0, 3, or 4, it's none of those. That's a quick check, you know, you really ought to then go through and double check it and plug in the -4 and 2, make sure it gives you a true solution. But that's it. So that's just solving an equation there when it's given to you as a rational expression on the left, rational expression on the right. You might want to approach it that way. Okay? Bring your questions to class.